When a user is looking at your geovisualization, um, his or her visual thinking is stimulated. Okay, so visual thinking is actually the media between your geovisualization and the user. And people usually use visual thinking to collect information from your geovisualization. Okay, visual thinking is the mental information processing through images instead of words, which means that we need to be careful about what and how people perceive when they are looking at your geovisualizations. And our visual perception is very powerful. Okay, when you're looking at a map, geovisualization, or anything, like when you're looking at a picture, a photo, or a random object in your life, you will always to find a specific pattern. For geovisualization, this pattern is usually a spatial pattern. A spatial pattern. Okay, so it's very important to make sure that your geovisualization is not conveying wrong perception to your users because it could happen. Okay, how? Let me introduce two words first. The first one is called apophenia, the human tendency to perceive meaningful patterns within random data. Okay, and another word is called pareidolia, a type of apophenia involving the perception of images or sounds in random stimuli, which means that even the pattern is not there, your brain will try to find out a pattern, no matter it is something you want or not. Here is an example. Obviously, this is an antique car, right? The face of an antique car. But when you're looking at it, you know that you can find a smiling face from this car because according to your experience as a human being, you can see two big cute eyes and a laughing mouth, right? So this is the pattern that is not there, right? Obviously, this car was not made for being funny, but you can still see the pattern. Another one is like this. I had made a grilled cheeses. When you're looking at that piece of bread, you can see there is a very typical figure of Jesus, right? You know that because you saw this figure as Jesus somewhere in your life. And when you're looking at this piece of bread, some of it has been burned, obviously, and the burnt part formed this figure of Jesus. Okay, so again, this figure of Jesus is another pattern your brain tries to tell you based on your experience, right? If you have never if you have never seen a figure of Jesus in your life, you may not see this pattern. Okay, so which means that our brain, people's perception is very sensitive to visualizations. You have to make sure that your visualization is not misleading them. That is not something you want. And we have this two-stage model for interacting with geovisualization tools in scientific exploration. When people are looking at a geovisualization, the first step is saying that they will always try to search for patterns in the visual input. And the second stage or second step is reasoning why. The judgment made before is carefully examined to identify errors or to explain a pattern or anomaly. And these two stages, they are iterated to collect more evidence for or to modify a judgment. So people are always uh, trying to find out a pattern and try to analyze this pattern and draw a conclusion, and then maybe they found errors, and then they will get back to the first stage to find more patterns, or try to find the correct pattern, and then analyze again, and then draw a conclusion. A pretty good example would be John Snow's 1854 Colora map. You may have seen this before. This is very famous thematic map. It's a pretty early and good combination of public health and geovisualization. So we can say this is a general purpose. It's a combination of general purpose map of a part of London and a thematic map. Specifically, it's a bar chart map, right? So we have small black bars within the central area of this map, right? So this map was made to find out the source or the medium of the infection of cholera in this cholera break in London. So we can say there are small bars along different streets, and the length of the bar is proportional to the number of infection cases along that street. So we can say that a lot of cases they are found here, right here, and here, right? Generally, this central area of the map, but we can find a pattern here. We can find a pattern. Although there are a lot of cases right here, and on the left side, on the central area, it's very strange that less cases are found here in this huge building, which is a workhouse. It's we can see this pattern because it's very strange. This warehouse, this workhouse is surrounded by a lot of cases, but within this area, for those people who are working or living here, less cases were found, which is weird. This pattern is weird because this house is very close to the area with a lot of cases. And back then, before this map, people thought that the bad air, a miasma, it's called a miasma, was the source of cholera, and cholera spreads through air. Okay, that word is called miasma, right? Miasma. But according to this map, it doesn't make sense, because if it is air, this warehouse here should also be severely infected. And from this pattern seen from the map, John Snow analyzed and found out that, okay, air, miasma, may not be the source of the cholera, of the disease. And eventually he found out that this warehouse here uses an independent water source. So that's the reason why this warehouse was not severely infected. So from the spatial pattern, John Snow found the source of the cholera, the media, the spreading media of this disease. So this is a very typical two-stage model. This matches the two-stage model we just discussed before, right? Firstly, when you're looking at this map, you find a specific pattern. And then from that pattern, you do analysis. And then you explore the data, you explore the space, and try to find out a conclusion, okay? And because people are, our brains, human beings' brains, they are sensitive to visualizations. They're always trying to find patterns from images and visualizations, but they're not always correct. So it's pretty important for us to know how to avoid errors or possible errors of pattern when we're making geovisualizations. The success of a geovisualization tool in scientific inquiry depends primarily on its ability of displaying patterns that can be identified and analyzed by a human viewer. Of course, this pattern should be correct, right? Should be correct. People could have wrong impression about the pattern shown in your geovisualization. And however, individual users recognize and notice patterns differently based on their individual experience. For example, some patterns, before the example, this sentence means that even we are facing, when we are looking at the same geovisualization, depending on our individual experience, we could find different patterns. And there are two types of arrows, right? So the first one is saying wrong, to say patterns where they do not exist. And the type 2 is not saying the pattern is there, but people are missing patterns that are really there. Okay, so the type 1 arrow is more common, but type 2 arrow also exists, and it can also be described, or it is also known as what? Scientific blindness. Blindness. The pattern is there, but for some reason you cannot see it. Okay. Example for type 1 arrow. One, you are looking at a picture. So how about this container loaders at this harbor, right? Do you see any pattern there? If you have ever seen a Star Wars movie, you know they look like something else, right? They are container loaders, but they look like this battling robots called, I think it's called AT-AT from Star Wars, right? So here, this pattern depends on what? Your own experience. If you have never seen Star Wars movie before, you would not find out this pattern. But if you have seen the movie before, you should be able to find this pattern. Okay, it depends on your experience. And in our geovisualization, we use visual variables to convey information, right? So there are different types of them. Point variables, linear variables, aerial variables, and each variable have a lot of features, such as size, shape, brightness, color, orientation, spacing, perspective, height, arrangement. Is pretty important, and actually is pretty hard for geographers to choose one of the categories and one or several features of a category to convey information. So people will find the correct pattern instead of arrows. Okay, so choosing and utilizing visual variables, they are crucial to your geovisualization, and they are pretty hard. And sometimes we use multiple visual variables to address the same thing, It's called redundancy, using or redundant symbolization. Okay, we have two examples here showing the same area of a city. On the left side, we have nominal level data, which means there are different categories. They are not, they are not quantified. Each category is just a name. Okay, so here, two visual variables have been used to show this single nominal level data variable. The first visual variable is color. A specific color is for a specific category. So we have 4 categories: red, blue, yellow, and green. And since this is redundant symbolization, another visual variable, which is the shape of each symbol here, has also been used for a category. Okay, the first category is circle, second one square, third one triangle, the fourth one star. So two visual variables for the same nominal level data. So this is a result. This is a result of redundant symbolization for this nominal level data. We can say that, I mean, personally, I don't think this is a good visualization or geovisualization because I think color is good enough. Different shapes, they look lively, they look fancy, but they are distracting. I would say that. So you should know that redundant symbolization can be tricky sometimes. You have to be careful of using it. On the right side, we have a good example of redundant symbolization. Okay, but this time, this map is trying to show the vacant houses within this area at different blocks, and it's ratio level data, which means at each block, a percentage of vacant houses is shown. So here, still two variables. First, the grayscale of green. We have dark green, a light green, even lighter green, until what? Until I cannot say it's extremely light green or just white. But the first variable here is the grayscale of green. Second is the size of the circle. The second variable is here. So the larger the circle, the higher the percentage of vacant houses, and also the darker the green, the higher percentage of vacant houses within that block. So here, neither one of the variables here is distracting, right? From the size of the circle, we can tell the general range of the data, of the percentage. We can also tell from the grayscale of the grain. Okay, so the application, the employing the use of variable is pretty important. Okay, and it's hard. Okay, I will stop here, and from next part, I'm going to talk about visualization methods and techniques. Thank you.